Hey guys, welcome to the 4th chapter of your science textbook, Carbon and its Compound. One who is speaking these lines, that is myself. And one who is listening these lines, that means you guys. The pen, pencil, clothes you are wearing and many stuffs are made up of carbon and its compounds. Let's start with the topics to be covered in this chapter. First, we will learn about carbon and types of its compounds. After that, we will learn about why carbon form covalent bond, not ionic bond. After that, we will discuss about properties of compounds formed by covalent bond. Next topic is versatile nature of carbon. After that, we will learn about hydrocarbons and their functional groups. At last, we will learn about nomenclature of organic compound. Let's start chapter by discussing some points about the element carbon. Carbon is a chemical element with symbol C and atomic number 6. It is a member of group 14 on the periodic table. It is non-metallic and tetravalent. That means it contains valency 4. There are 3 naturally occurring isotopes. 12C and 13C are stable, but 14C is radioactive. There are 2 types of carbon compounds, organic compounds and inorganic compounds. Organic compounds are made up of carbon and form the basis of all living organisms. Inorganic compounds are chemical substances that are not organic in nature. Inorganic compounds consist of carbonate and bicarbonate compounds along with oxides of carbon. So, how carbon forms different types of compound? It does so by forming covalent bonds by sharing of electrons. A question arises, why carbon form covalent bond but not ionic bonds? As we know, carbon having valency 4. So, in order to form positively charged ions, we get C4+, and in order to form negatively charged ions, we get C4- ions. C4+ formation would be difficult because it would require a large amount of energy to remove 4 electrons, leaving behind a carbon cation with 6 protons in its nucleus holding onto just 2 electrons. Considering C4-, it would be difficult for the nucleus with 6 protons to hold on to 10 electrons. Thus, carbon cannot form ionic compound. Carbon can form covalent bond. Covalent bond, as said earlier, is bond formed between 2 atoms by sharing of electron. Some of the examples of covalent bond formed compounds are H2, Br2, N2, O2. There are 3 types of carbon compounds. First, single covalent bond. Second, double covalent bond. Third, triple covalent bond. In single covalent bond formed by sharing of 2 electrons, one from each of the 2 atoms. Example, formation of hydrogen molecules, H2. Here, you can see 2 hydrogen atoms share their each electron and form covalent bond between them. In double covalent bond, the bond is formed by sharing of 4 electrons, 2 from each of the 2 atoms. Example, formation of oxygen molecules, O2. In O2 gas, 2 oxygen atoms share their 2 electrons each within themselves. Triple covalent bond formed by the sharing of 6 electrons, 3 from each of the 2 atoms. Example, formation of nitrogen molecule N2. In the N2 molecule, you can see two nitrogen atoms share 3 electrons each within themselves. Let's discuss few properties of compound formed by covalent bond. We will also make a comparison with compounds formed by ionic bond. Covalent bond formed compounds have weaker intermolecular force of attraction, while compounds formed by ionic bond are having a stronger intermolecular electrostatic force of attraction. Thus, we can say covalent bonds are weaker bond compared to ionic bonds, since the intermolecular force are less in case of covalent bond. They are having lesser melting and boiling point compared to ionic bond form compounds. Covalent bonds are generally poor conductor of electricity because they are formed by sharing of electrons. They don't have free electron that is required for electricity transfer. Next topic is about versatile nature of carbon. That means ability of carbon to form varieties of carbon compound. There are various reasons for the same. First is catenation. It is ability of carbon to form long chains. Second reason is tetravalency. That means 4 valency of carbon. A carbon atom can form covalent bond with other 4 atoms. Another property of carbon responsible for its versatile nature is isomerism. It is the property by which carbon compounds having same molecular composition exhibits different structures. Next topic is hydrocarbons. Compounds made up of a hydrogen and carbon is considered as hydrocarbon. Most of the clean fuels we use, CNG, LPG, are hydrocarbons. There are 2 types of hydrocarbon. First, saturated hydrocarbon, and second is unsaturated hydrocarbons. First, we will learn about saturated hydrocarbon. It contains only single bond between carbon atoms. There is no existence of double or triple bond. Alkanes are saturated hydrocarbons. General formula of alkane is CnH2n plus 2. If you replace n by any integral value, you will get a chemical formula of a saturated hydrocarbon. Example are methane, CH4, putting n equals to 1, ethane, C2H6, putting n equals to 2. Similarly, chemical formula of other saturated hydrocarbon can be obtained. Coming to unsaturated hydrocarbons. The unsaturated hydrocarbons are those which are having at least one carbon-carbon double or triple bond. Alkenes and alkynes are unsaturated hydrocarbons. Alkenes are hydrocarbons having at least one carbon-carbon double bond. General formula of alkene is CnH2n. First, alkane is ethane, C2H4. Alkynes are hydrocarbons having at least one carbon-carbon triple bond. General formula of alkyne is CnH2n minus 2. First alkyne is ethyne, C2H2. Functional group is an atom or a group of atoms which, when present in a compound, give specific properties. In hydrocarbon chain, one or more hydrogen atom is replaced by other atoms. Heteroatom are those atoms which makes carbon compound reactive. Homologous series, a series of compound in which some functional group substitute hydrogen in carbon chain. Example, CH3OH, C2H5OH. Two homologous series is differ by CH2 group and their difference in their molecular mass is 14 mu. They possess same chemical properties but show gradual change in physical properties. Nomenclature of organic compounds. Nomenclature is the process of naming a particular group of things in a certain pattern. There are a number of carbon compounds due to versatile nature of carbon. The problem was how to name all of them. Certain ways were developed to name carbon compounds. There are two types of nomenclature of organic compound. First one is common name. The names are given after the source from which organic compounds were first isolated. Example: CH3OH, methyl alcohol. Another way of nomenclature was developed by IUPAC. IUPAC stands for International Union of Pure and Applied Chemistry. IUPAC gives rules for naming various organic compounds. Rules for naming organic compounds are: first, at first we will identify the number of carbon atoms in the compound. Second, after that, functional group is written by suffix or prefix. Third, if the name of functional group given as suffix, the last letter E in the name of compound is deleted and suffix is added. Fourth, halogens group are written as prefixes. So that's all for now. The next topic are dealt in second part of the video. Thank you.